we had simplifying algebraic expressions, right? And all we did here was um, simplify as far as possible, okay? In this case, we have to distribute, right? Because I have a number in front of a quantity, and that quantity includes two terms because it's separated by a plus or minus, right? All right, so I'm going to go ahead and distribute. 4 times x is 4x. 4 times 2 is 8. And then I have to do the same thing uh, to the second set. A positive 6 times x is positive 6x squared. Now, you guys know that when we multiply variables, you add the exponents, right? When you multiply or divide variables, you add or subtract the exponents. E plus E, right? Exponent plus exponent. When you're adding or combining like terms, say I want to take x to the first, add or subtract. Obviously, subtract you would minus. So I have x to the, I don't know, second plus 2x to the second. You do not, you leave that exponent alone, right? You get 3x squared. So when you multiply, say I have x to the third times x to the third, you add those together. So I have x to the sixth. See the difference? Add the exponents when you multiply. And when you add terms, leave that exponent alone. It's pretty easy to forget, all the way from back to Algebra 1, which your crappy COVID year. Hey, I just came up with a good saying. Crappy COVID year. That's legal to say. Um, then I have to distribute the 6x to the minus 5. So 6x times minus 5 minus 30x. Now in this one, I have, I do have some terms I can combine. I have x to the first terms, right? So I'm going to start off with my 6x squared because I like putting it in, standard form, highest degree to lowest degree. And what else I got? 4x to the first, a minus 30x to the first gives me a minus 26x to the first. And then I have my constant plus 8. I don't have any equal sign or anything, so that's as far as I have to go. I see the air conditioning's working great in here today, huh? Anybody else hot? It's sticky in here, is what I'm saying. All right, so you get to do B. Let's look at 2A. Any questions on that? All right, number 2A. 3x, I need to distribute over the parentheses. So 3x times x, 3x squared. 3x times minus 9, minus 27x. Now be careful here because I need to distribute a minus 2x. Minus 2x times an x is a minus 2x squared. Good. Minus 2x times of 1 is a minus 2x. Okay, let's combine some like terms. See, here's my x squared terms. So positive 3x squared minus 2x squared is a 1x squared. If you want to put a 1 there, that's fine. And then I can combine the x to the first, right? Negative 27x to the first minus a 2x to the first minus 29x to the first. There's my answer. And then on day 2 of 1.3, we did no, we did it on the same day. We did evaluating where they give us values for the variable and we would substitute them in wherever we see that variable. Okay. And I told you guys the easiest thing to do here so you don't make too many mistakes, put parentheses wherever you see the variable. Minus 5y squared. Then go back and plug in your values. X is 4, y is negative 7. And this is a perfect example of what I was talking about. If you didn't have parentheses in your calculator, if you just put negative 7 squared without the calculator, without the parentheses, you get the wrong answer. Okay, negative 2 times 4 is negative 8. Let's see. I got to do exponents first, right? Negative 7 squared, or negative 7 times negative 7, 49. Negative 8, and then multiplication's next on PEMDAS. Negative 5 times 49. Let's see, 45, carry the 4, negative 20, plus 4. And then now I can subtract. Okay? Negative 8 minus 245 is negative 253. Okay, number 4A. Let's see. This is kind of skewed here. Let's see if I can do a better job. There we go. Okay, again, we're going to evaluate. My x is negative 2, so wherever I see a negative 2, I'm going to plug in. I'm sorry, wherever I see an x, I'm going to plug in negative 2. And then y is 3. So you're going to put a 3 there and a 3 here. Now, obviously, you don't have to put all the arrows and stuff. I just do that for teaching. But you should put in the parentheses. So I have 8x squared minus y all over x plus 3y squared. Okay, so x is negative 2, negative 2. Y is 3. We'll get a 3 here and a 3 there. And then I told you guys, if it's a fraction, make sure you do the top and the bottom separate, the numerator and denominator separate. And the last step, you're going to divide it out. All right, so this equals 8. I have to do my exponents first, right? Negative 2 times negative 2 is positive 4. That's negative 2 squared. Minus 3. Then I have negative 2 plus, I have to do my exponents before I multiply. Don't multiply and square it. Do the exponent first. So I have 3 times 3 squared is 9. Okay, 8 times 4 is 32 minus 3. And then I have to do the multiplication on the bottom, right? Negative 2 plus 27. 32 minus 3, 29. Negative 2 plus 25, 7 is 25. I don't know if that reduces, so I'm going to check it. 29 divided by 25. Enter. Math. Enter. Enter. And no, it does not reduce. All right. Oh, and then we did word problems. Yay. Yay. A rental company charges you $25 per day and 30 cents per mile when you rent a mid-sized car from them. The model represents your total cost. Write a model that represents this situation. Specifically, identify what your variables represent. Okay. So it's up to you whether you want to do the verbal model or not. I kind of I don't really do them, but if you want to, we can. Let's see. The model represents your total cost. So that's what we want to equal, right? Total cost is going to equal, let's see, the amount per day and it's going to um, include the cost per mile times the number of miles, right? Okay, so let's get some variables for this. Let's see, the total cost is what we're supposed to find, so we need a variable for that. T is going to equal the total cost. Let's see, what else is a variable? They give us the amount per day, they give us a cost per mile, but they don't tell us the number of miles. So I'm going to need a variable for that. So I'll use M for miles, each mile, right? Then I'm going to go back and plug in my model. So I have my total cost, which is T equals the amount per day, which they give us, right? $25 plus the cost per mile, which is 30 cents, times the number of miles, which is M. And that's it. Because they only told us to write an expression, right? Write a model. So we're done. Watch the directions. Okay. All right, number 6A. Any questions on that? I know you guys can probably skip the verbal model and stuff, but you have to put down the algebraic model and what those variables are. Okay. This you will have to put on the quiz. 6A. Your team is setting up a computer program for a popular burger chain. At this store, if you make a single $3 donation, each burger costs 99 cents. But the first three burgers are free. using C to represent the total cost, K to represent the number of burgers ordered, create an algebraic model to calculate the customer's total bill. Bless you. Assume we only sell burgers today and everyone will order at least three. So they actually define the variables for us, right? So I'm going to do my verbal model. Let's see. Total K represent model to calculate the customer's total bill. So my total bill is going to equal the donation, right? Plus for each burger, the cost of each burger times the number of burgers, right? But we got to be careful because the first three are free. So I'm going to have to oops, minus three burgers. They define the variables for us. Let's see, C to represent the total cost. It's going to equal the donation, which is $3 plus the cost of each burger, 99 cents, times times the number of burgers, which is K, and then we have to minus those three. I guess I should have defined the variables. C equals total bill, and K equals number of burgers. Any questions? You guys look really bored and tired today. It is Thursday, right? It's Friday Eve. You should be excited. No? Nothing? Got nothing from it? Last section we did solving equations. So we have to get the variable by itself, right? Isolate the variable. That's what solving means. Okay, number one, I have a number in front of the quantity, so I have to distribute. So 8 times x, 8x, 8 times minus 3 minus 24 equals 2x minus 5. Now, be careful here. I, if you're messy and disorganized, use that dotted line or a line to help you out there. It really does prevent you from making simple mistakes. Now, I like to keep my x term, variable term positive, so I'm going to subtract 2x from both sides. 8x minus 2x, 6x. I'm going to bring down my minus 24. These add up to 0. Have to bring down my minus 5. Wow, there's a lot of coughing and sneezing going on. Did you notice that? I hope you're not going to spread your germs because pre-COVID, I used to get sick like that from you guys. And then I yell and make funny comments about you guys being sick and spreading it and giving me your diseases and germs. I don't know. I see a plague coming. All right, gotta add 24 to both sides. Well, you guys don't get my humor today at all. Wow, tough crowd. Tough crowd. All right, 6x equals what, 19? Divide by the coefficient 6. Let's see, that means x equals 19. 6. Can we reduce that? No, we can't. 19 is a prime number. Any questions? Okay, number 8 is a double distribution problem, one on each side. Negative 4 times x, negative 4x. Negative 4 times negative 2 is a positive 8. 5 times 4 is 20. 5 times positive 3x, positive 15x. Okay, I'm going to add 4x to both sides. Over here. So I get 8 equals 20 plus 19x. Subtract 20 from both sides. Let's see, 8 minus 20 is going to be negative 12 equals 19x. Divide both sides by 19. And we still can't reduce here, can we? Negative 12 over 19. Questions? Oh boy, two more to go. All right, number 9 is a what? Yeah, it's a proportion, so we can cross multiply. Please do yourself a favor and put parentheses there. By 6 times x plus 7, and then 3 times x minus 2. We're going to distribute 6 times x, 6x, 6 times 7, 42, 3 times x, 3x, and 3 times negative 2, negative 6. Solve for x. See, I'm going to subtract 3x. Gives me 3x plus 42 equals 0. Bring down the minus 6. See, subtract 42 from both sides. So I'm going to get 3x equal negative 48. Divide both sides by the coefficient. 3. So x is going to equal negative 16. And then everybody's favorite, the fractions that we did. Aren't you happy it's on the quiz? Not one smiling face. Okay, so the best way to do this is by the LCM, right? You could list out everything, right? The 2, the 4, the 5, and the 10, and write down the multiples. But I'm going to use a shortcut. I'm going to try the highest denominator, 10, and think to myself, well, does 5 divide into 10? Yes, it does. Does 2 divide into 10? Yes. Does 4 divide into 10? No. So I'm going to try the next multiple of 10, 20. Does 5 divide into 20? 2 divide into 20? 4 divide into 20? It's my little shortcut. Not much of a shortcut, but so I'm going to multiply every fraction by 20. Now you could use a calculator for this if you're, if you want to. So 20, can you guys see that? 20 times, just remember to put fractions in parentheses, is 8. So I have 8x minus 20 times 3 divided by 2. I get 30 equals 20 times 7 divided by 4. I get 35. There's an x there, right? Minus 20 times 3 divided by 10. I get 6. Okay, I'm going to subtract 8x from both sides. I'm going to bring that minus 30 down, equals 35x minus 8x, 27x. Bring down my minus 6. Okay, I'm going to add 6 to both sides. Negative 30 plus 6, negative 24 equals 27x. Divide both sides by the coefficient 27. And I do believe that that reduces. Let's see, 24 divided by 27. 8/9. So negative 8/9. You guys look like you had so much fun with that. You want to do the back page? Wow. At least a couple of smiles on that one.